Welcome to the Explainer. Today, we're unpacking the absolute backbone of server-side Java programming. If you've ever interacted with a complex, data-driven web app and thought, what on earth is doing the heavy lifting behind the scenes to make this run so smoothly? Well, you're exactly in the right place. Today, we're demystifying Java servlets.
Okay, let's dive into this. Think about it. How does a static web server, which is, let's be honest, basically just a glorified file cabinet handing out static HTML documents, suddenly generate dynamic, personalized content on the fly? That fundamental problem of the early web, that is exactly what servlets were built to solve. Here's our roadmap for today. 1. The dynamic web solution. 2. How servlet architecture works. 3. The 4-stage lifecycle. 4. Anatomy of a web app. And 5. Building your first servlet. Section 1. The dynamic web solution, overcoming the limitations of early web tech.
Now, what's really interesting about this slide is how things used to be handled. Before servlets, developers relied heavily on CGI, or Common Gateway Interface. But CGI was a total resource nightmare. It literally created a brand new process for every single request. That meant huge resource consumption, super expensive overhead, and broken states. Like, it couldn't even natively handle cookies. Java servlets swooped in as the scalable hero. They are incredibly efficient because they handle multiple requests within a single shared process model. Plus, they seamlessly manage stateful data, like those cookies we mentioned, and they're highly portable. It was a real game changer.
So let's formally define what we're looking at here. A Java servlet is basically a server-side Java program that handles client requests and generates dynamic responses, and it does so efficiently and scalably. Running on a Java-enabled web server, it's specifically designed to manage that entire request-response lifecycle. And because of this portable efficiency, servlets have really become the absolute backbone for building robust enterprise applications. Section 2. How servlet architecture works. Peeking under the hood at the container. To really grasp the architecture, we absolutely have to talk about the servlet container. This is the integrated runtime environment that manages Java servlet components right on top of the web server. Think of it like a bustling restaurant. The web server is the host at the front door, right? Greeting clients, taking those initial requests. The servlet container is the restaurant manager. It's providing all the essential services behind the scenes, like network communication, managing resources, decoding messages, and providing security. And the servlet itself? That's your expert chef in the kitchen, taking the order, processing it, and preparing the dynamic meal to be served right back to the customer. Let's walk through the exact journey of a request so you can see this in action. Step 1. The client, let's say it's your web browser, sends an HTTP request to the web server. Step 2. The web server receives it but realizes, hey, I need dynamic content for this. So step 3, it passes that request over to the corresponding servlet via our container manager. Now step 4 is where the chef gets to work. The servlet processes the request, maybe queries a database, and generates an output like an HTML page. Step 5, the servlet hands that fresh, hot response back to the web server. And finally, step 6, the server sends it over the network back to the client where it renders beautifully on your screen. It is a perfectly choreographed system. Let's move to and see how this builds in Section 3, the 4-stage lifecycle, from instantiation to garbage collection. You see, the life of a servlet is strictly managed by its container through 4 very specific chronological states. First up is startup. This is where the container loads the servlet class into memory and actually instantiates it. Next is the one-time setup, or initializing phase. This is absolutely crucial. The servlet prepares itself. Maybe it sets up a database connection or something similar. And this stage literally only happens once in the servlet's entire lifetime. After that, we enter the active phase, handling client requests. This happens per request over and over again for every single user. Finally, when the server shuts down or just needs to free up memory, we hit shutdown. The servlet releases its resources, is destroyed, and heads off for garbage collection. Now, those abstract timeline stages map directly to 3 core Java methods in your code. The init method handles that critical one-time setup we just talked about, your database connections and so forth. Then you have the service method. This is your real workhorse, taking in those client requests and delegating them to do get or do post depending on the need. And lastly, the destroy method. This is basically your cleanup crow, called exactly once at the very end to pull the plug and neatly sweep up memory resources. Section 4. Anatomy of a web app, structuring your enterprise application. Whether you deploy your app unpacked as separate files or packed neatly into a single WAR file archive, the folder hierarchy always remains consistent. At the very top, you have the document root. This holds all your public static content.
your HTML, JSP, CSS, and images. But the real magic? That happens inside the web-in folder. Now, this is a highly secure server-side folder that is completely hidden from web browsers. Inside web-inf, you're going to find the web.xml deployment descriptor, along with a classes folder where your compiled Java classes and servlets actually live. If a user tries to type a URL pointing directly into that web-in folder, the server will immediately block it. It is strictly for internal mechanics. No outside access allowed.
So how do a user's browser actually find your application from the outside? Well, you need a context path. This is a unique name assigned to your deployed web app. Think about it. When a web server is hosting dozens of different applications all at the same time, the context path tells the server exactly which app the browser is looking for. So if your context path is /myfirstservlet, adding that to the end of your server's base URL routes the user's request straight to the document root of your specific application. It's like the exact street address for your app on that server. Section 5. Building your first servlet. Practical implementation in NetBeans. Historically, connecting Java code to a web URL was honestly a bit of a tangled mess. Developers had to rely on clunky XML configuration inside that web.xml file just to map URLs to specific servlet classes. It really dragged you down. But starting with Servlet version 3.0, we got a massive upgrade: annotation configuration. So the crucial point is how brilliantly streamlined this new approach is. By simply typing the @webServlet annotation, like @webServlet/hello, directly inside your Java code right above the class, the pieces fit together instantly during startup. No more endless XML files to maintain. And generating the dynamic response itself is incredibly straightforward. And this brilliantly illustrates how much it operates like an automated assembly line. Inside your method, you just set the content type, say to text/HTML. Then you grab a printWriter object. From there, you just use out.println to dynamically construct your HTML right on the server. That tiny bit of code acts like a robotic arm, perfectly assembling your dynamic data, pushing it across the network, and rendering the final polished hello right onto the user's screen. From solving those massive process overhead problems of the early web to providing an incredibly sleek, annotated request-response lifecycle, servlets are just a remarkably durable tool in the Java ecosystem. They give you the power, the structure, and the performance you need to handle thousands of requests completely seamlessly. So my final question to you is this. Now that you understand how the container operates and how the lifecycle flows, how will you use Java servlets to build your own scalable enterprise applications? It's time to open up your IDE, spin up an Apache Tomcat server, and start coding. Thanks for joining me on this explainer, and I'll catch you next time.